So now let us just draw the the projected characteristic curves, and for that let's just draw it here, right? This is your x, this is your t, and x negative. See, so basically this r is varying in this line, right? X is, so when r is negative, x is equals to r. So essentially it will look like this, no? The projected characteristic comes, it will look like this, x equals to r. Okay, and let's say this is your x equals to 1. So for x greater than 1, you have these projected characteristics, which is u equals to 0. So essentially x equals to r here itself. So x equals to r. Okay, now and r is between 0 and 1. You have x equals to t plus r. Okay, so in between r 0 and 1, x equals to t plus 1. So those are lines with slope 1. Okay, so these are the projected characteristics. Now as you can see that there is a shock. Where is the shock? When this line x equals to t plus r, that for any r, for r between 0 and 1. So basically let me write it down. So essentially we have shock. Okay, we have we have shock. We have shock when the lines x equals to t plus r for r between 0 1 and x equals to 1 intersects. Clear? Why shock? Because suddenly you see you will have, for every point here, wherever they intersect, so they are intersecting everywhere, right? I mean from on this line x equals to 1, every point on this line is getting intersected. So if you want to find the value of u there, what is going to happen? That will be a multivalued function, because along these characteristics that is going to be 1, and along these characteristics this is going to be 0, right? So these are this is kind of a shock curve, you can say. Okay, there is a shocking here. Okay, and there is a rarefaction wave also. And where is the rarefaction wave? See this part, rarefaction. Why? Because as you can see, you remember the earlier thing, here we do not have any much information. Okay, so here we have a blank thing. So this is, and there is a rarefaction wave there. We get a rarefaction wave. Okay, where the rarefaction wave between x equals to 0, and x equals to t. Clear? This is x equals to t line, that line, this line. I hope this is fine. X equals to t line. Okay, so x equals to t and x equals to 0. So between this whole thing, there is a rarefaction wave situation going on. Okay, of course this also intersects somewhere at x equals to t equals to t less than equal 1. No? T less than equal, up till t less than equal 1, there is no problem. After that it intersects. Okay, so you have to deal with all of that, all of these issues. So let's do that. So the first thing first, let's just think of a shock curve. Okay, which is, since it is emanating from x equals to 1, the shock curve. Okay, let's just think of, there is some shock curve. Okay, so basically let me again draw some pictures here. I hope this will be enough to convince you. This is x equals to 1, x-axis, d-axis. Okay, and the shock curve starts from here somewhere. Okay, so here it starts from somewhere. So let's just draw it like this. I'm not quite sure what that looks like right now. Okay, let us just do that and then we'll see what it looks like. Okay, so you see, of course there are projected characteristics in this part, right? And those projected characteristics, what is u? U in this case is u equals to 0. If you remember, u equals to 0 here. Okay, u is 0 and u is 1. U is 0 in this side also. Okay, if you remember, see u is 0 along x equals to r, u is 0 along x equals to r for this. So in these parts where they are not touching anywhere, so u is 0, that's not a problem here. Here also there is no problem, u equals to 0. So essentially you see, if you just look at this particular graph, this diagram, essentially if you just draw it like this, let me again draw another part. See, x equals to 1, these curves are there, and x equals to t plus r, they intersect here. Okay, and these up till this part they also intersect here, right? So these are the characteristics. See, that's the intersection. In this part, u is of course 0. U is of course 0 here. You don't worry about it. So essentially, you see in this part also, this parts u is 0. This part u is 0. Okay. My issue here is only in this region. My issue here is only in this region. What happens here? Do you understand? Okay, because the curves, projected characteristic curves intersect. Here there is no intersection. You see, here means these parts. Here there are no intersections. All of these areas. Okay, so this area is given by this. This is the same area. Okay, so here there are no intersections. So u equals to 0 here, u equals to 0 here. That was given to us. I don't know what is happening in this area. That is the point which I want to look at. Okay, of course, if there is a shock curve that starts from x equals to 1. Right, so and what is the speed of the shock curve, that we need to find out. So how do you find out the speed of the shock curve? For that we want to use the Rankine-Huggenite condition, right? So by Rankine-Huggenite condition, again as I told you, RH condition, whenever I am writing, it means Rankine-Huggenite condition. Okay, I hope I have explained to you earlier also. Okay, whenever we are writing RH condition, I did not explain. Maybe I explained it in the earlier videos. So you see, there are some things which we are always going to use in this course. Whenever I am writing this a small phi, most of the times if it is not mentioned, we think of this phi as some function, a particular function, okay, which will be given to us. So in our case, this small phi is, you see, this small phi is the data curve, initial data curve, small phi. Okay, if this phi anywhere in the assignments also, if it is written like this, this is the capital phi. Okay, so you see, if it is written like this, capital phi of x, let's say, yeah, then you guys already know that is the fundamental solution, right? Of what? Fundamental solution of Laplace equation. Okay, solution of Laplace equation. Again, you also know that if it is written like this, capital phi of xt, if it is written like this, it is the fundamental solution of heat equation. Okay, so do not get confused here. Whenever I am using capital phi in this course, always it will mean fundamental solution unless it is explicitly mentioned what is capital phi. Capital phi is always fundamental solution. Small phi is always some arbitrary function. Yeah. Okay. Now again, and also RH condition, if I am writing RH condition, you can also use this in your examinations if you want. You write only RH condition, it means Rankine-Huggenite condition. You don't have to write the whole Rankine-Huggenite condition. Okay, just write RH condition. Okay, so the RH condition, what does it give? It gives the speed of the curve, sigma. So I want to draw some curve, this curve, I want to find what this curve is. So sigma is the jump of f of u by jump of u. Okay, and f of u here is, see, in this case, this is a Burger's equation, right? So f of u is u square by 2. It is written here, f of u is u square by 2, right? So you see here, it will be given by u minus plus u plus by 2. If you just break it up, it is going to be this, right? Okay, now let's see what happens. See, on the other side, u is going to be 0 here. It is always, u plus is always going to be 0. Okay, so I don't know what is u minus, but u minus also here, from here you can see that I mean, if this has to satisfy in these areas, u minus is going to be 1, right? Right? I mean, because of the initial condition, you see, initially it is getting carried out like 1, okay, up till x equals to 1, it is getting carried out. So I am starting out with the data curve such that I want u to be 0 on the other side, this side u equals to 0, and on that side u equals to 1, because just to match the initial conditions. Okay, so I want u, so u minus is 1, u plus is 0, and by 2. So this is half. So the speed of the curve has to be half. So therefore the shock curve, okay, how do I put it? The shock curve, shock curve. So basically our curve x equals to xi t. If you remember, shock curve is given by, here it is not x, it is x minus 1, because it starts from 1, right? So it means x minus 1 equals to half t, sigma t, right? That's the shock curve. If you remember, sigma is the slope of that. Okay, so essentially what is happening, the slope is half fixed, so essentially what is happening is this shock curve will look something like this. Clear? I hope this is fine. Maybe I can, okay, 1 second, let me okay, let me just draw it properly. Okay, see the shock curve from here, this is x equals to 1, this is the x-axis, it starts from here, it goes on like this. So this is x minus 1 equals to t by 2. That's the shock curve. Okay, why it is like this? Because you see it starts from x equals to 1, yeah, so that is why it looks like this. So x equals to 1, and in this whole region, u plus is going to be 0. Clear? Okay, now I don't know what is u, so I have to find what is u in these parts, right? Okay, so this is a shock curve. I know u plus is going to be 0 here. What is u minus here? I know that u minus here, you see, since there is an initial condition given here, what is the value of u here? It is 1, right? And it is getting carried forward. So on one side of the shock curve you can write it as 0, and the other side of the shock curve you can write it as u equals to 1. I hope this is fine. Why? Because of the initial condition. Okay, but is it always 1? No, it is not always 1. It is 1 up till x equals to t. X equals to t. So this line is x equals to t. Okay, so in this part it is 1. Is this clear? See, I mean, we have to worry about this part. This part, in this part, u is 1 because of the initial condition. I am taking it to be like this, and on the other side of the shock curve, and I am extending it. Okay, I am extending it up till here. So u is 1 up till in this area. Here u is 0. Here u is 0. In this part, u is 0. Okay, so because on the other side of the shock curve, you want u plus to be 0, u minus to be 1. So u is 1 in this part. Is it 1 here? No. Okay, because there is a rarefaction wave going on. You see, here there is a rarefaction wave going on. Okay, so I don't know what is there there. So for that I have to worry about the rarefaction thing. Now you guys already know that if you have a rarefaction thing, it is g of x by t, where g is f prime inverse, right? And in our case, when f is u square by 2, you guys already know that what is it? This is given by u equals to x by t, right? So in this area, let me draw it like this. This area, u is given by x by t. I hope this is fine. U is x by t. You remember last this thing exercise also we did this. Yes, in the last exercise we did this thing. So again, let me just write it down. That of course, I don't know. Oh, okay, of course. Okay, u is equals to x by t in the region, which region, x equals to 0 and x equals to t. Clear? So in that region, up till t equals to 1, of course, after t equals to 1, this is going to be, u equals to x by t. That is always there. Okay. Now, because you see, now my new shock curve is this. Here it was intersecting, there was a problem, so we constructed a new shock curve along which one side it is 0 and one side it is 1. Okay. Now this particular x equals to t, that intersects somewhere, right? This x minus t equals to 3. So see, at t equals to 0, now at t equals to 2, okay, x minus 1 equals to t by 2 and x equals to t intersects. Okay, so again same problem will happen. You do understand? Again, if they intersect, again the same problem will happen. Okay, so and now I hope this is fine. What I'm trying to say. See, if you now, so if you are defining u to be 1 0 in this area whole u is 0. Clear? U equals to x by t in this wedge, x equals to 0 and x equals to t. Between x equals to 0 line and x equals to t line, I am taking u to be x by t. This is the rarefaction thing. That is why I am just doing it like this. U equals to 0 on this area. You know that x minus t greater than t by 2, that area. Okay, this area. Okay. Now this area equals to 1 because of the initial conditions are dictating that, right? Okay, u equals to 1 between x equals to t. And x equals to t plus x equals to x minus 1 equals to t by 2. Okay, between this area, u is equals to 1, that we have. But what is happening here is this. See, if you move forward in this point, t equals to 2. Let's say this is t equals to 2. Okay, x minus 1 equals to t by 2 and x equals to t. These two again intersects. Okay, when it intersects, what is happening is this. You see, along the there is another the rarefaction. So basically this is the rarefaction wave, right? Here these waves are rarefaction waves. These rarefaction waves, they actually hit the shock wave. This is the shock wave, right? X equals to, see, I'm sorry, let me use a different color. I think that will be better. You see, this is the shock wave. This is the shock wave. Okay, and this is the rarefaction wave. X equals to, see, this is the rarefaction wave. X equals to t, right? X by u equals to x by t here on the rarefaction wave. So basically they get intersects here, right? Now whenever they are intersecting, then also we have another issue, right? How do you deal with that issue? That's the question which we need to answer in this part. Okay, so let's just do that. I hope this is fine. Again, see, I am explaining it to you. It may not be 100% clear to you. What I want you to do is, you take your pen and pencil, sit down with this exact example, okay, and try to write everything down. Think about what is happening. Okay, so please do that. I can do my best to teach you, but the thing is, until unless you do it yourself, you won't understand what exactly is the problem. Okay, so here what is happening is, at this point the rarefaction wave and the shock waves intersects. Okay, and now what happens is, so we need this jump now. I have to have another curve something from here, which will actually has to satisfy the Rankine-Hughes condition for our solution to exist, because from there, this point onwards, the solution again does not exist. Okay, so what happens now? Intersects, and we have a problem, right? So basically the rarefaction wave and the shock wave intersects. So maybe I can put it like this: the rarefaction wave and shock wave intersects. Clear? Okay. Now I have to do all of this all over again. So what we have to do is, now again, you see, so from this point, okay, I have to draw another curve, okay, such that u minus is x by t, because you see u is x by t in this part, okay, and u is 0 on this part. Okay, so I have to draw another curve. So basically by Rankine-Hugenoid condition, so I will start with another curve which starts from this point. You understand what I am trying to say? Since it intersects here, I will start with another curve. Okay. So what I am trying to do here is this, and the point is given by 2 by 2, 2, 2, t equals to 2, x equals to 2, this point. Okay. So so by Rankine-Hugenoid condition, again Rankine-Hugenoid condition, okay, what is the sigma here? That is jump of f of u by jump of u, okay, which is given by u minus plus u plus by 2. Okay, what is u minus? U minus here it is given by x by t. Okay, and what is u plus? It is 0. So this is x by 2t. Clear? I hope this is clear. Okay, therefore you have a new shock curve. Okay, so therefore we have a new shock curve. I know this is a little intimidating, but first, if you do it for the first time, but I mean, you just take some time. I mean, give yourself some time. Think about what is exactly happening. Okay, this is not very difficult thing to understand. We have a new shock curve. Okay, this is emanating. So basically, we are manipulating solutions. That's all we are doing from the point 2, 2. Is this clear? Okay, so let me draw the new. Okay, so you see in this part, of course, u is going to be 0. If you remember, u is going to be 0 in this part. Okay, you see u is 0 in this part. Okay, and so let's say this is 2, this is 2, 2. Okay, and x equals to 2 here, x equals to 1 here. Okay. Oh, right. Now x equals to 1. So x equals to t line goes like this. Let's say. Yeah, it does not look like x equals to t, but let's just hope this is x equals to t. Okay, that's x equals to t, and this line actually x minus 1 equals to t by 2, that intersects somewhere at 2, 2, right? So this line is x equals to, this line is x equals to what is it? 1 plus t by 2, right? Right? Clear? Okay. Now here u is 0. Yes, here u is 0. Clear? Here u is x by t. Here u is 1. Okay, but from here there is an intersection at 2, 2. What do we do now? So to get, okay, so both the lines are gone. Let me just draw another one. Okay, I hope this is fine. Okay, so x equals to t line, this one, x equals to t. Let me write it like this: x equals to t, and this line is x equals to t by 2 plus 1. Clear? Okay, now this intersects at 2, 2. So from here there is a new curve emanating from here. Okay, so let's just assume some curve. Okay, some curve emanating from here. What is the curve? The slope of that curve is given by x by t. So therefore since the speed is given by x by 2t, right? Therefore the curve is given by x t, x as a function of t is root 2 t. Clear? I mean, you just put it in the problem and you can get it. It's not a very difficult thing to see. Okay, I hope this is fine. I'm not calculating all that. I'm just writing it down. Okay, so now the new curve from here, it starts from 2, 2. Okay, it starts from 2, 2. That curve, it starts from here, and it's so basically some parabolic kind of thing that will go on up. I mean, that will be our new shock curve. This will be our new shock curve. Okay, now, so what is the solution? Let's just write down the solution. Okay, so this is a little complicated now. Let me write down the solution. Okay, so the weak solution. So there are two shock curves. The weak solution are given by given by u of xt is the first one, if you remember, 0 for x negative, x by t when 0, x lies between x equals to 0 and x equals to t, x by t, right? It is 1 where here you see where is it? Yeah, 1 in this wedge, this part, okay. So basically between x is between t and t by 2 plus 1, right? And it is 0 when x is greater than 1 plus t by 2. I hope this is actually fine, okay. This holds for t less than equal to, right? Because up till t equals to 2 this is true, t equals to 2 up till t equals to 2 this is true, right? After t equals to 2 you have a new shock curve, okay. So and for t greater than equal to, okay, what do we have? U of xt is given by 0, okay, if x is x negative. Of course, if x negative, I mean x negative u is 0, you don't have to worry about it. Again, if x lies here, so x is greater than equal root 2t in this part, okay. See, I mean think of this as in this part, if x is greater than root 2t, this is x equals to root 2t, right? That line, that curve. So x greater than 2 root 2t, it is going to be 0 because u equals to 0 in this part. That's not a problem, right? Okay, and u is x by t in this part. Clear? Okay. So u is x by t if 0 less than x less than root 2t, and it is again 0 if x is greater than root 2t. Okay. I hope this is clear to you. Okay, this is the weak solution which we get. Of course, this is a weak solution because I mean, does it the Rankine Huguenot condition? Of course, it holds because you see we have manipulated our solution like that itself. Okay, because we had derived it using those things, so that will hold. Okay, and of course, you guys can check that this is also going to the entropy condition is going to be satisfied, right? So this particular solution is a admissible weak solution. Okay, hence u is a admissible weak solution. Weak solution. Okay, so if you are not convinced, please check it yourself. Okay, but I mean this is the admissible weak solution which we have obtained. Okay, so with this we are going to end this video.